Hello guys, this is Ronit from Mathics, and today we're going to be doing number 18 from the AMC 8 of 2019. Now, this problem, in my opinion, does not deserve the place of number 18, because when you get down to the problem, all you have to do in this problem is just some simple multiplication, and you know the basic rules of odd plus odd, even plus odd, and even plus even. Basically the stuff you learned in kindergarten. But anyways, let's get started. The faces of each of the two fair dice are numbered 1, 2, 3, 5, 7, and 8. When the two dice are tossed, what is the probability that their sum will be an even number? And the answer choices to this problem is A, 4 over 9, B, 1 over 2, C, 5 over 9, D, 3 over 5, and E, 2 over 3. Okay, so when you get down to this problem, you have to read the end of it, because I'm pretty sure you might have not understood what it says in the end. Because in the end, it says, what is the probability that their sum will be an even number? So, to get that probability, we have to first figure out what you can do to get an even number. Okay, so to get an even number, you can do the basics of math. And what I mean by that, I mean the even odd. So, what we know about these two words that can describe the two different numbers is that one is even and one is odd. And when you apply them in the mathematical sense, like let's say 8 is even, because we know that, and 2 is even, when they add it up, there are 10. So 10 is also even. So after seeing that example, we can justify that even plus even is equal to even. And even if you don't believe that from just one method of math, you can look all throughout the math world, because there are infinite examples of even plus even is equal to even. So that's true. Even plus even is always equal to even. Now we're on our second method, and that one is odd plus odd, because when you add an odd plus an odd, you'll get an even, such as 3 and 7. That is equal to 10, which is even. So that means odd plus odd is equal to even. And again, there are infinite examples of this. Let's say maybe 9 and 11. They both are odd, but when they're added up, they're 20, because odd plus odd is always equal to even. And now we're on to our third one. Now this third one isn't actually necessary in this problem, because this problem says what is the probability that their sum will be an even number. And this third one is even plus odd. And this one's not necessary, because they asked us what's the probability that their sum will be an even number. And I'm going to tell you that the even plus odd, that's equal to odd. Such as 3 plus 2. When you add those, you get 5, which is odd. And just like the first and second one, there are infinite examples of this. 8 plus 7. 11 plus 12. And also 21 plus 22. So this shows you that even plus odd is always odd. Not necessary, but it's helpful to know this. So anyway, how does this really matter in this problem? Well, guess what I'm going to tell you. Because these numbers here that they showed us, the faces of each two dice, are numbered 1, 2, 3, 5, 7, and 8. And when the two dice are tossed, what is the probability that their sum will be an even number? So these numbers are important, because what you want to do here is separate the odds and the evens. So you see the set that 1, 3, 5, and 7 are odd, and 2 and 8 are even. Now, if you don't get what that means, that's okay, because we're setting apart these odds and evens, because each of these are on one dice. 1, 3, 5, 7 is on one dice, and 2 and 8 is on that same dice too. And what we want to see for a probability that their sum will be an even number is that if both the dice are rolled and they add up to an even number, then that's the case. And what we can see here is that since there are 4 odds on one dice and there are 4 odds on the other dice, if you roll both of them and they each have the 4 odds and then the other one has the 4 odds, and each time you roll it you get one odd paired with another odd, then that would be each case for an odd sum, like odd plus odd is equal to even. So basically, we can count those cases easier because if there are 4 odds on one dice and 4 odds on the other dice, and you roll them, it's basically going to be 4 times 4 for the amount of even cases that are added up from the 2 odds. And that is equal to 16, meaning that there are 16 even sums that are added up by 2 odds. Now, for the other one, 2 and 8. So, for 2 and 8, we can do the same thing that we did in the previous one for 1, 3, 5, and 7. Because in 2 and 8, these two numbers are each on the dice. Dice number 1 and dice number 2. So, what we did in the first part is that since there are 2 of the numbers on one of the dice and 2 in the other one, there are going to be multiple cases because 2 could go with 8, 2 could go with 2, 8 could go with 2, and 8 could go with 8. And instead of counting those, we could just multiply it like we did previously. So that would just be 2 times 2, which is equal to 4. Meaning that since now we got each individual of the cases, for 2 times 2 equals 4, this 4 being an even sum of 2 evens, and 16 being an even sum of 2 odds, we can just add these both numbers from the odd plus odd equals even and even plus even equals even to just have an even sum pile, meaning that 20 is going to be the even sum pile, the pile of all the even sums that are added up regardless of odd and even. So currently we have got 20, and this 20 is going to be the numerator of the probability case, because we have to put this 20 over the amount of sums there can be. And this one is just going to be easy, because since there are 6 numbers here, that means we can do what we did previously, and since there are 6 numbers on one dice and 6 numbers on the other dice, and when the dice for each of the phase are added up together, there will be 36 cases, because what we did previously for the 4 times 4, we just had 6 times 6. So 20 would be over 6 times 6, which is 36. And when you simplify that, we will be getting 5/9. Meaning, the answer to this problem is 5/9. Showing you that this problem was nothing more than just some multiplication in a kindergarten topic. And I guess you could use fractions too. But anyways, as you can see, we have finished this problem, meaning that we're now officially finished.